Alright, the last chapter that you guys have to know for the test coming up is 2.7. I think it probably is the, maybe the most challenging of the sections, perhaps. Alright, and so you might want to pause it now and read the steps here, so you kind of know what I'm doing before I do it. Alright, so I pretend that this is an equation instead of inequality. So that's the first thing I do. So I say, alright, y equals, and you don't even really need to write it out like I'm doing. Oh my gosh, that's the worst. 3x minus 5. So y equals 3x minus 5. So it is a linear equation. Let me fix the 3. Okay, so it's 3x minus 5, linear equation. Alright, so you just pretend that it's an equation. So in slope-intercept form, whichever section in chapter 2 that talks about it, you learn that how you graph this is that you graph the y-intercept first, so that's a minus 5. That's the minus 5 here, so down 5. 1, 2, 3, 4, 5. Okay? And then the 3 tells you that the slope is 3 over 1. So I go up 3 over 1, up 3 over 1, up 3 over 1. And so we have a line. Boom, there we go. Slope 3, y-intercept negative 5. So let me make the dashed line here. Oops. Still on the pens. Boom, boom, boom. And I want a dashed line. Okay? Because it's less than, or excuse me, it's greater than. So it's exactly like in inequalities when you're only working with one variable where you shade in the circle sometimes and sometimes you don't. It depends on whether or not it has the or equal to part of it. And in this case, it's just greater than, so the way that idea is communicated is that you do the dashed line. Okay? Okay, so that's communicating the fact that any point on this line is not a part of the solution to this inequality. Okay, none of the points on the line make it so that y is greater than 3x minus 5. So if you pick any point on this line, let's pick an easy one. Okay, say 0, negative 5 is the easiest one I can see. And so what you do, oops, let me get the big one. To show what I'm trying to get at is that you plug in 0, negative 5. So negative 5 is greater than maybe 3 times 0 minus 5. And you verify that, wait, that's not true. Negative 5 is greater than negative 5. No way, Jose, that's false. Okay, and so when you're graphing these things, the idea is you're graphing all the ordered pairs that actually work, and what we just figured out is the boundary of that region, okay, but the boundary of that region actually doesn't work if you plug it in. If you plug in any number on this line, it doesn't work in this inequality. Negative 5 is not greater than negative 5, all right? So then what you have to do in step 2 is determine which way, this is the boundary to the region you're going to graph. And step 2, you plug in an ordered pair to see which side of this boundary is what you're actually going to shade in. And you don't have to do it this way, but the easiest XY combo is 0, 0 usually. And I don't know why it's doing that. I'm not telling it to do that. It's very confusing. 0, 0. So pick x equals 0, y equals 0. And the only constraint, this is important because it might come up here and there, here or there, is that you cannot plug a point on the line itself. So you got to pick one side or the other. And 0, 0, so really pick 0, 0 unless the line is going through 0, 0, unless it's going through the origin. Otherwise, just pick 0, 0. So you go, all right, 0 greater than 3 times 0 minus 5. Is that true or not? 0 greater than negative 5. Yeah, true. So what that means is you shade on the side with that ordered pair. So 0, 0 is right here. So you're going to shade on the upper left side. So let me pause for, I want to get a better highlighter here. and then you shade over here, right, which is to the left of the line, but it's also above the line if you think about it. And that is actually the other way you can figure out which way to shade, is that just look at what's going on with y. Y is greater than the stuff. So you're going to shade where y gets bigger, and that's up. Okay, and that only works, only works if y is by itself in the equation. If it is not, you got to go through it like I did here. Okay? Okay, either way will give you the right answer. So let's do another example, but with standard form. Okay? So 2x plus 3y is less than or equal to 12. Let's do different colors for the heck of it. So what you do is you graph it. And so the easiest way to graph when you're given standard form is you find the intercepts. Okay, so you pretend it's an equation. And so if you don't remember how to do this, what you do is you temporarily pretend that y isn't there. Because really what's up is you're saying, hey, what happens when y equals 0? Because when y equals 0, that's the x-intercept. And so apparently, when y equals 0, you get 2x equals 12, x equals 6. So this is the x-intercept. Whoa. Weird. Alright, x-intercepts over here. Okay? And then do the opposite. To find the y-intercept, we go 6 y equals 12. Remember, we're pretending it's an equation. Y equals 2, so that's the y-intercept. And then we just connect the dots with the diagonal line. So trying to color coordinate here, boom. And I screwed up. It's supposed to be solid, so let me fix that right now. And it's supposed to be solid because it is, let me get this sucker out of the way, it is less than or equal to. So if you see an or equal to, it's going to be a solid line. Alright? So then what you do, the same thing that we just did on the previous example, you test a point, and usually the origin will work, and here that's true as well. So you plug in, so let me duplicate and bring it down. So you plug in 0 and 0 for x and y. So you're testing the point 0, 0 right here at the origin, and you're seeing, alright, 2 times 0 plus, I'm showing way more work than you would need to show. You might just know be able to tell right away. So x is 0, y is 0. That's the origin, that's this point here. If this works out to be true, then you shade towards that point. If not, then you shade away, and then look here, it works out to be true. This is a true inequality. 0 is less than or equal to 12, less than in particular. So I'm going to shade everywhere on this side of the inequality, which is below. Alright. Please forgive my lack of being able to stay in the lines very well. This is harder than it looks. Alright, but hopefully you get the idea that you would shade below. Alright, so there you go. Hopefully that's enough help that you guys can handle 2-7. At least with a little bit of extra instruction in class maybe, if not just already.